Modern data analytics include data processing, data transformation, data projection, and all need an efficient storage system, which is usually a NoSQL solution. But what if your data constantly grows or shrinks under volatile load? Your storage deployment needs to be flexible, that is, elastic. Meet Elton, a cloud resource elasticity manager for NoSQL databases. Elton can automatically scale out or in your NoSQL cluster to meet the current demand. Through a monitoring interface, you're able to follow the elasticity process and access historical log data about the least resources based on the incoming load of your deployment. Elton offers an analysis service to help you understand the resource elasticity decisions and supply what-if analysis to obtain a better perspective of your cluster. Its novelty is that it integrates probabilistic model checking with optimization of resource usage. Let's see Elton in action running inside the Ganetimgr, an open-source cloud resource management system for Ganeti with advanced features. Selecting the elasticity from the side panel, we move to the Elasticity Manager's overview. Here, we can create, start, stop, edit, or delete elasticity managers. Let's create a new one. In this form, we set the elasticity deployment configuration. The configuration is split in 3 sections. The first section is about the configuration of the NoSQL cluster. We specify the NoSQL database. Here we select Apache Cassandra, the cluster initial, minimum and maximum size. The second section is about the elasticity management. We specify the decision policy, the utility function providing a latency threshold, and the punishment value if this threshold is violated. The prediction algorithm and optionally a smoothing algorithm for the incoming load. The maximum allowed additions and removals. For expert users, several low-level details are also offered that manipulate the underlying Markov decision process model, like the number of clusters for the logged measurements and the option whether to cluster all the violating measurements into the same cluster, the look-ahead horizon of our model, and the number of transient steps after VM addition to allow the system to stabilize before the next elasticity decision. The third section is about the deployment of the cluster. We have 2 options, emulated or real deployment. In both options we can define a training set for the decision maker, or Elton will produce one for us. Optionally, we can define an hourly cost for the deployment to mimic an Amazon EC2 deployment. In the emulation mode, we specify the length of the emulation, every unit is considered as 30 seconds in real deployment, and the emulated incoming load. We can upload our own text file with a load or provide a function to produce one with some added options. Let's create the manager and then start it. In the monitoring page, we can monitor running deployment or display diagrams from previous deployments. We provide interactive graphs displaying the cluster size in accordance to the incoming load and response latency of the system. Statistics about the current cost, if an hourly cost is provided, and the NoSQL deployment are also provided to the panel on the left side. A key feature of Elton is the analysis interface. Here, we can apply what-if analysis to better understand the resource elasticity decisions and fine-tune the cluster or the elasticity manager configuration. More specifically, in this presentation, we ask for the maximum probability of a latency threshold violation if we disable both the additions and removals from a previous time step right before an addition.